Hello dear learners, it's me again, Lev, and today I will show you 10 forms of energy that we have around the world. These 10 types of forms of energy will help you understand many interesting areas in physics. So what I'm going to do right now is I'm going to list them from 1 to 10, and for each and every form that I mention, I will tell you a little bit about it. A little bit of side information that might be interesting for you to know. As you can see in this diagram, there are two main categories that I will divide our 10 forms of energy in. On the left hand side we can see kinetic energy, which is energy that comes from movement. And whereas on the right hand side we can see potential energy, which is energy that basically is stored inside matter. To describe how potential and kinetic energy works as simple as possible, I will use the example of the roller coaster. As you can see, when the roller coaster moves upwards, this roller coaster construction, the potential energy of it rises. And while it's going downwards, the kinetic energy is rising again. And now again the potential energy. So the knowledge that we can extract out of this animation is that when the roller coaster moves upwards, it has potential energy, and when it moves downwards, it has kinetic energy. Another example would be if I would climb up a mountain, I would need potential energy, and I would also have potential energy. But when I'm up there and I'm finished enjoying the view, and I'm deciding to throw myself off the entire mountain, I'll have kinetic energy along the way. Now let's look at the energy forms from the kinetic energy side. If we have got a pot full of water placed on a heated platform, this heated platform will convert its energy onto this pot filled with water and will have its effects on the water as well. As you can see, the water starts to boil and yeah. Mechanical energy. Mechanical energy is the sum of potential energy and kinetic energy. It is the energy associated with the motion and position of an object. The principle of conservation of mechanical energy states that in an isolated system that is only subject to conservative forces, the mechanical energy is constant. This is also what the physics professor in the background here in the video is trying to prove with a massive wrecking ball that could crush his head, but it doesn't, since physics is correct. Electrical energy. The use of electrical energy is highly important in the modern industrial world. Electric currents turn motors and drive machinery. Electric currents provide the energy of labor-saving appliances, such as power tools, vacuum cleaners, and dishwashers. Clearly, the currents can do work and thus possess energy. Magnetic energy. In ancient times, men knew of a special kind of rock that could pull other rocks of the same kind and pieces of iron towards itself. Such rocks were called lodestones. In modern times, man uses the same force exerted by the ancient lodestones to generate electric power, to store information in computers, and to study the secrets of the universe. Now let's look at our energy forms from the potential energy side. Chemical energy. When several chemicals are mixed together to form gunpowder or dynamite, A violent explosion can occur if care is not taken to prevent this. An explosion can do work against the force of gravity, for example by throwing pieces of material into the air. A mixture of chemicals that can do this work is said to have so-called chemical energy. Elastic energy. Elastic energy is the potential mechanical energy stored in the configuration of material or physical system as work is performed to distort its volume or shape. The slingshot stores the potential energy when it's not stretched, but as soon you release the rubber string of the slingshot, kinetic energy is released by it. Nuclear energy! Energy is produced when the nuclei of atoms are either split, fission, or united, fusion. Fission occurs when a heavy nucleus splits into two more lighter segments. Fusion is the combining of two light nuclei to form a single heavier nucleus. The energy released by the fission or the fusion of nuclei in the form of heat, light, or other radiation is called nuclear energy. Last but not least, gravitational energy. Gravitational energy is the potential energy held by an object because of its high position compared to lower position. In other words, it is energy associated with gravity or gravitational force. It is the force that keeps the planets in orbit around the sun. Oh, and not to forget both of the energy forms that are neither kinetic nor potential. Sound energy. Sound energy is a form of energy associated with the vibration of matter. Every kind of sound is produced by vibration. The sound source may be a violin, an automobile horn, or a barking dog. Whatever it is, some part of it is vibrating while it is producing sound. The vibrations from the source disturb the air in such a way that sound waves are produced. These waves travel out in all directions, expanding in balloon-like fashion from the source. Light energy. One of the most familiar and important forms of energy is light. Nothing is visible to humans when light is totally absent. But light is even more important for other reasons. Many physicists believe that millions of years ago, light from the sun triggered the chemical reactions that led to the development of life on Earth. In the animation, you're right now seeing a hydrogen atom with a nucleus in the middle and one electron moving around it. As soon as a photon hits this hydrogen atom, its electron gets elevated to a higher energy level, as you can see in the animation. But it wants to go back to its old stage again, so it does that by emitting another photon, emitting the exact light wave of that hydrogen atom. So what you've learned right now is that a photon, which is the lightest and also fastest thing that we physicists know nowadays, has enough energy to bump an electron into a higher energy level. Here is a short review on kinetic and potential energy. So for potential energy, I have when I pick this cat up, but when I let it fall down, there is kinetic energy.